All right, everybody, last proof here. So here we're given that we're given this isosceles triangle XYZ, the large triangle, and we're given that XY is congruent to XZ. So XY and XZ are congruent. We're given that MP is perpendicular to YZ, and so is NQ perpendicular to YZ. So we have a couple perpendicular lines there. Okay, and we're also given that M is the midpoint of XY and N is the midpoint of YZ, right? So we're given that this, we'll get into that as we go. I should get a little ahead of myself there. Okay, and we're trying to prove that MP is congruent to NQ, all right? So hopefully you can see a path here, and hopefully as you're getting more used to these proofs, you can kind of see a path. Even if you can't, mentally go through every single step, hopefully you can kind of see, okay, I think this is where we're headed with this one, right? So there's another one that you might want to split up. I'm at least gonna take out the big triangle here and put it out here on its own. So I'm going to start with XY is congruent with XZ. Okay, so XY is congruent with XZ. And then I'm going to put in all these other givens. MP is perpendicular with YZ. And NQ is perpendicular with YZ. All right, and then we can say M is the midpoint of XY and N is the midpoint of XZ. All right, so a lot of places we can go with the givens, right? So first of all, I'm going to start with, I'll just go from what's given first. So if we know that these are congruent, right? It's an isosceles triangle, so that means the base angles must be congruent, right? And so that means angle Y must be congruent with angle Z. Oops, I said Y but wrote X. Angle Y must be congruent with angle Z. All right, and the reason why is because of the isosceles triangle theorem. All right, so I have it on the big triangle here, but I'm going to write it into the smaller triangle as well. Okay, all right, and then let's see, next let's talk about these perpendicular values, right? So if we have perpendicular lines, then it follows that we have right angles, right? So we know that angle MPY, and so this angle here, MPY, and angle NQZ must be right angles. Are right angles. And we know that by definition of perpendicular. Definition of perpendicular lines, to be more specific. Okay, and then now we have the midpoints, right? So what do midpoints tell us? That tells us that we have some congruent segments, right? We know that XM must be congruent to MY. Let me write that in here. Segment XM must be congruent to segment MY. And also, XN must be congruent to NZ. Okay, and that is by definition of midpoint, right? Because the midpoint by definition divides a segment into two congruent segments. All right, so we're getting close, right? We have right triangles here, and we have the hypotenuse. Well, we have the So we don't know the hypotenuses are congruent yet, right? We know that these are congruent, and we know that these are the midpoints, right? So it seems like if we cut two things that are the same in half, then their halves would be the same, right? And that's true, but we have to prove it. We have to explicitly get from point A to point B with that logic chain. So we're going to say, hey, well, by the segment addition postulate, we can say that xm plus my, and let me do this measure of y's. All right, so xm plus my equals xy, right? And we can say that xn plus nz equals xz. And that's by segment addition postulate. Right? And we know that, and I should have, I could have done this in here, but I can do it this next step. So I can say, well, I know that xm is equal to my, right? Because if they're congruent, that means their measures are equal. Same thing with xn and nz, right? So if that's the case, I can actually subtract. Well, let's do it. Let me do one more here, actually. Let me say that since I know xy and xz are congruent, I can say that their measures are equal, right? Their lengths are equal. So I can say all that by definition of congruence. Congruent segments. So if the segments are congruent, their angles, their lengths must be the same. Okay, so now that we have that, now I can use the transitive property to say, hey, if these are equal, that must mean these are equal, right? So I can say, okay, well, xm plus my must equal xn plus nz. All right. And since these are the same, I can substitute I can substitute my in for xm, right? Those are the same. So I can say my plus my equals. And then on this side, I can substitute nz in for xn. So I can say nz plus nz, right? And the reason why I'm doing nz and my are because those are the ones that I want to prove are congruent. Okay, so I did that by substitution, right? So here I did transitive property. Here I did substitution. Okay, and then here we're just adding these together. 2my equals 2nz, and so we can divide by 2. And for this step, you can say computation or addition, or combining like terms. Do that. Here we can divide by 2, so we can say my equals nz. And that's the division property of equality. All right. So that means if those are equal, that means the segments must be congruent if the lengths are equal. So definition of congruent segments. All right, so now we can say, hey, well, this segment here is equal to this segment here, right? So now we have hypotenuse, we have this angle, we have these are right angles. So at this point, I'm not seeing a hypotenuse leg. Actually, what I'm seeing is, okay, well, why don't we just say these right angles are congruent, and then we can say angle, angle, side, right? We can say angle, angle, side. So that's what I'm going to use on this one. So I'm going to say, okay, well, angle, since these two are right angles, they must be congruent. Angle MPY is congruent with angle NQZ, because all right angles are congruent. All right, and then now we can say, okay, well, that means the triangles have to be congruent. MYP is congruent with triangle NZQ, and that's by AAS. And then finally, we can say, okay, well, if those are congruent, that must mean these corresponding parts are congruent, right? So MP must be congruent with NQ, right? MP, NQ corresponding. And that's by CPCTC. All right, and that's it.